They are known as unquenchable machines of obliteration that eat up all that crosses their inestimable way, dark holes, the most gigantic structures in the universe. These celestial phenomena have forever been among the most fascinating objects we encounter in the colossal spread of space. Once something passes the event horizon of a dark hole, there can be no escape. No radiation, no information, and certainly no matter can ever cross this cosmic boundary from the inside to the outside. Because of these amazing properties of dark holes, an interesting question arises. What would actually happen if one of these structures came perilously close to our blue home planet? In today's video, you'll discover what consequences this scenario would bring and what defines dark holes beyond that. Join us on our cosmic journey to explore the greatest mysteries of the universe. Don't forget to subscribe to Just Space and click on the bell to stay up to date. Also, go ahead and show us with a thumbs up that you like the content of our posts. Dark holes. As mentioned at the beginning, the gravity of dark holes is so strong that nothing can escape their event horizon from the inside to the outside. This also includes light beams, which leads to the fact that these stunning objects can never be observed directly. However, with the help of indirect evidence, the presence of these exceptional phenomena has long been undeniably proven. The defining characteristic of dark holes is that their immense mass is concentrated in a very small volume. Specifically, the entire mass of a dark hole is condensed into a single point, which has an infinitely high density and an infinitely strong gravitational field. This cosmic compactness, called a singularity, ultimately gives dark holes their unique gravitational pull. The corresponding gravity is so strong that it warps space in the immediate vicinity of a dark hole. This phenomenon, which has been confirmed through numerous astronomical observations, was already predicted by Albert Einstein in his world-famous general relativity theory. However, there are also vast differences in the types of dark holes. These fascinating entities can be classified into distinct groups based on their formation processes. Stellar dark holes. The simplest to understand are the so-called stellar dark holes. These form when a star of a certain size exhausts its fuel and ultimately collapses. Following this stellar demise, the outer layers of the star are ejected in a supernova, while the remaining core compresses under its gravitational pressure into a highly compact body. Thus, the stellar dark hole is born. Given that the intrinsic mass of a dark hole is highly concentrated, a dark hole with the same mass as our Sun would have an event horizon with a diameter of just over 3 miles. As a reminder, the diameter of our Sun is a staggering 9 million miles. Supermassive dark holes. The origins of supermassive dark holes are a much greater mystery. In fact, experts have not yet been able to understand how these entities formed. What is certain is that supermassive dark holes have masses millions to billions of times greater than the Sun. Scientists believe that almost every galaxy's center hosts one of these supermassive structures. Supermassive dark holes also play a central role in the formation and evolution of galaxies. Our home galaxy, the Milky Way, is no exception. The supermassive dark hole at its center, named Sagittarius A*, has a mass of approximately 4.3 million solar masses and is located about 26,670 light-years from Earth. Some luminous bursts in the vicinity of Sagittarius A* suggest that there may be up to 20,000 other dark holes within a radius of about 70 light-years, constantly orbiting their more massive counterpart. Other types of dark holes. Many experts also hypothesize the existence of medium-mass dark holes, which may have a few hundred to a few thousand solar masses. These could possibly arise from stellar mergers, though their existence has not yet been definitively proven. A particularly unusual type of dark hole is the so-called micro-dark hole. Some theories propose that the minimum mass for these unique structures is far below the official Planck mass. Accordingly, micro-dark holes could potentially form in particle accelerators. Some scientists consider this theoretical scenario to pose a potential risk to our blue home planet. They fear that such a micro-dark hole could fall into Earth's core, expand there, and ultimately absorb the entire planet. A dark hole at Earth's core. The question of what would actually happen if Earth encountered a dark hole has also been investigated by Frank Kyle, a particle physicist at Stanford University. A small dark hole, with dimensions comparable to a grain of sand, would already have a mass equivalent to that of our planet. If such a structure were to appear in Earth's core, it would have extraordinary effects on life as we know it. Kyle emphasized that dark holes derive their destructive properties not only from their sheer mass but also from the extreme heat and radiation intensity surrounding them. If matter from Earth's core began falling into the small dark hole, it would be compressed to an extremely high density and heated immensely. These intense temperatures would generate various radiations, such as gamma rays and X-rays, which would heat up other matter crossing the event horizon. This effect would manifest as a strong pressure exerted on Earth's outer layers. Over time, the extreme gravitational forces and heat would destabilize the planet, leading to catastrophic consequences. They are known as unquenchable machines of obliteration that gobble up all that crosses their inestimable way, black holes. The most gigantic structures in the universe have forever been among the most fascinating objects we observe in the vast field of space. Once something has passed the event horizon of a black hole, there can be no escape, no radiation, no information, and certainly nothing can ever again cross this cosmic boundary from the inside to the outside. Because of these astounding properties of black holes, an intriguing question arises. What would actually happen if one of these structures came dangerously close to our blue home planet? In today's video, you'll discover the consequences of this scenario and learn more about what characterizes black holes. Want to join us on our cosmic journey to uncover the greatest mysteries of the universe? Then don't forget to subscribe to Just Space and click on the bell icon to stay updated. Also, show us some love with a thumbs up if you enjoy our content. Black holes. As mentioned at the beginning, the gravity of black holes is so strong that nothing can pass their event horizon from the inside to the outside. This includes light beams, which leads to the fact that these incredible objects can never be observed directly. However, through indirect evidence, the existence of these unique phenomena has long been unquestionably proven. The central characteristic of black holes is that their immense mass is concentrated in a very small volume. Specifically, the entire mass of a black hole is concentrated in a single point, which has infinitely high density and an infinitely strong gravitational field. This cosmic minimization, called a singularity, ultimately gives black holes their extraordinary gravitational power. The corresponding gravity is so strong that it bends the space in the immediate vicinity of a black hole. This phenomenon, which has been confirmed through numerous astronomical observations, was first predicted by Albert Einstein in his world-famous general theory of relativity. However, there are significant variations among black holes. These extraordinary objects can be classified into distinct groups based on their individual formation mechanisms. Types of black holes. The simplest to understand is the origin of so-called stellar black holes. These formations arise when a star of a certain size exhausts its fuel and collapses. Following this stellar death, the outer shells of the star are ejected in a supernova explosion, and the remaining core compresses under its gravitational pressure into an extremely dense body. A stellar black hole is born. Due to their concentrated mass, stellar black holes are incredibly compact. For instance, a black hole with the same mass as our Sun would have an event horizon with a diameter of just over 3 miles. For comparison, the diameter of the Sun is approximately 864,000 miles. The origins of supermassive black holes are an even greater mystery. Experts have yet to understand fully how these objects form. What is certain, however, is that supermassive black holes have masses millions to billions of times greater than the Sun. Scientists believe that nearly every galaxy's center hosts one of these supermassive entities. Supermassive black holes also play a central role in the formation and evolution of galaxies. Our home galaxy, the Milky Way, is no exception. The supermassive black hole at the center of our galactic home is known as Sagittarius A star. This structure, which contains about 4.3 million solar masses, is located approximately 26,670 light-years from Earth. Bright flares near Sagittarius A** suggest that up to 20,000 smaller black holes, with a radius of about 70 light-years, orbit their larger counterpart. Some experts also hypothesize the existence of intermediate mass black holes, which have hundreds to thousands of solar masses and possibly form from stellar mergers. However, the existence of this class remains unproven. A particularly unusual category is that of micro-black holes. Some theories suggest that the minimum mass for these structures is far below the official Planck mass. Micro-black holes might even form in particle accelerators. Some researchers fear that such a micro-black hole could fall into Earth's core, grow, and eventually consume the entire planet. While this scenario is deemed highly unlikely by most scientists, it brings us to the central topic of today's video: what would happen if Earth encountered a black hole? A black hole at Earth's core. The question of what the actual consequences of this hypothetical scenario would be has been pondered by scientists like Kyle, a particle physicist at Stanford University. A small black hole, with the apparent size of a speck of dust, would already have a mass equivalent to Earth. If such a structure were to appear at the planet's core, it would have radical effects on life as we know it. Kyle notes that black holes derive their destructive properties not only from their immense mass but also from the extreme heat and radiation they generate. If matter in Earth's core were to begin collapsing into the black hole, it would be compressed to extremely high densities and heated enormously. This intense heat would produce gamma rays, X-rays, and other forms of radiation that would also heat surrounding matter falling into the black hole. This effect would manifest as an intense gravitational pull exerted on the planet's outer layers. Eventually, Earth itself would be entirely consumed, marking the catastrophic end of our blue home.